Hello everyone, good morning. My voice is audible, right? Good morning, good morning. Yes, good morning. Yes. So this is lecture number 7 of analytical geometry, and we are going to start straight lines in this class. So in the previous 6 classes, we have completed direction, cosines and direction ratios and planes, right? So if you haven't watched all the previous classes, watch all the previous classes before watching this class, right? Because direction, cosine and direction ratio is very important concept to understand the planes as well as straight lines also, right? So we will start straight lines in this class. So first, what we will do is we will define straight line. There are two forms of straight line. One is symmetrical form. The other is general form, right? Symmetrical form of equation of line in symmetrical form and the equation of line in general form. So there are two forms of equations of line. So we will discuss those two forms and then we will do some problems based on that, right? Yes. So first what we will do is we will discuss about what is the equation of straight line in symmetrical form, right? So equation of straight line in symmetrical form, first we will discuss that, right? Just a minute. Yes. So first what we'll do is we will define symmetrical form of equation of line, right? Very important. Symmetrical form of equation of line. So symmetrical form of equation of straight line. So recall all the previous concepts, right? Especially direction ratios, direction cosines, angle between lines. If you know direction cosines and angle between the planes, so recall all these, right? Because all we will be using in this class. Okay. So first, what we'll do is we will define what is the equation of straight line in symmetrical form, right? Let us have a line, right? Everything is in 3D only, right? See, in 2D, y is equal to mx plus c is the equation of line. There are many forms of equation of line, right? Y is equal to mx plus c and y minus y1 is equal to m into x minus x1. If you know one point and one slope, there are many forms of equation of line. But that is in 2D. But here everything we are discussing only in 3D only, right? Three-dimensional only. Everything will differ here. Okay. So we are going to find the equation of this straight line. First will be in symmetrical form, right? So let us take a fixed point A, right? Let us take a fixed point A and call this as alpha, beta, gamma. Let alpha, gamma, beta, gamma, gamma be any fixed point on the straight line. Let let A, alpha, beta, gamma be a fixed point on the straight line. On the straight line, right? So we have a fixed point A on the straight line. Let us take an arbitrary point, right? Let us take an arbitrary point. Let us call that as x comma y comma z, right? So let P be any point on the line. Let P of x comma y comma z be any point on the line. Be any point on the line. So we have a fixed point and I'm taken an arbitrary point P, which is x comma y comma z on that line, right? On that line. Let this line as direction ratio a comma b comma c. So let a comma b comma c be the direction ratio of the line. So we have assumed three things. One is fixed point, other is a variable point, anything you can take which is x comma y comma z, and this line has direction ratio a comma b comma c. Then the equation of line is given by then then the equation of straight line equation of straight line in symmetrical form. And the equation of line in symmetrical form is given by, very easy, x minus alpha divided by a, y minus beta divided by b, z minus gamma divided by c. ABC is the direction ratio of the line. Alpha, beta, gamma is any fixed point on the line, right? So that means if you know a point on the line, and if you know direction ratio, you can form the equation of straight line. Very important point. I'll repeat. If you know any one coordinate on the line, and if you know direction ratio of the line, if you know any one coordinate, and if you know the direction ratio, you can write the equation of the straight line, right? What is that? X minus alpha by a, y minus beta by b. Alpha, beta, gamma is the one coordinate that you know. So to write the equation of line symmetrical form, you should know one point on the line and direction ratio of the line. So if you know two data, then you can write the equation of straight line, which is x minus alpha by a, y minus beta by b, z minus gamma by c. Let us say it is equal to some k, right? Because all these are equal, right? Let us say it is equal to k not equal to 0, k not equal to 0. So now what can you say about the format of the coordinates? So any point, any coordinate, any coordinates on the line will be of the form. See, what is x? X is ak plus alpha, right? See, x comma y comma z is any coordinate. This is arbitrary only, right? Now you solve for x y z. So x minus alpha by a is equal to k. That means x minus alpha is equal to ak. So x is equal to ak plus alpha. And similarly, what is y? Y minus beta by b is k. So y minus beta is equal to bk. So bk plus beta. And z minus gamma is equal to k. So z minus gamma is equal to ck. So ck plus gamma. So any point, any coordinate will be of this form only. That is any coordinates on the line will be of the form ak plus alpha, bk plus beta, ck plus gamma. Alpha, beta, gamma is a fixed point on the line, and ABC is the direction ratio of the line. So any point on the coordinate will be of this form only, right? So whatever point you take, that coordinate will be of the form AK plus alpha, BK plus beta, CK plus gamma. Is it clear about this slide? So equation of straight line symmetrical form is x minus alpha by a, y minus beta by b, z minus gamma by c is equal to k. And to write the equation of straight line, we should know a point on the line. That is, you should know the coordinate, any one coordinate on the line. You should need to know any one coordinate on the line, and you need to know direction ratio. Then you can write the equation as x minus alpha by a, y minus beta by b, z minus gamma by c is equal to k. Right? So based on this, we're going to do 7 problems now. Based on the single concept, we're going to do 7 problems. Okay. So we'll move on to first problem. Yes, so we'll move on to first problem. So find k so that the two lines are perpendicular to each other. So they are given two lines and they have said they are perpendicular to each other. X minus 1 by minus 3, y minus 2 is equal to 2k, z minus 3 by 2, and x minus 1 by 3k, y minus 5 by 1, z minus 6 by minus 5, right? So they are given two line. You need to find the value of k so that they are perpendicular, right? So they are perpendicular. So you can see it is in symmetrical form, right? X minus alpha by a, y minus beta by b, z minus gamma by z. So you should always write in this format. Suppose if this is not in this format, means you would have to try to bring in this concept. You should always have in this format x minus alpha, y minus beta, z minus gamma, a, b, c. So you can see these two lines are perpendicular. That means what? What is the direction ratio of this line? Now, what is the direction? What is the direction ratio of this line? Minus 3, 2k, and a 2. And what is the direction ratio of this line? It is 3k, 1, and a minus 5. So, since they are perpendicular, the corresponding direction ratio must satisfy the condition for perpendicularity. A1, A2 plus B1, B2 plus C1, C2 is equal to 0. So, since they are perpendicular, A1, A2 plus B1, B2 plus C1, C2 has to be 0. So A1, A2, that is minus 9k, B1, B2, so 2k, C1, C2 equal to 0. So we will have minus 7k minus 10 is equal to 0, minus 7k is equal to 10. So k is minus 10 by 7. So when k is minus 10 by 7, they will be perpendicular, right? Okay. So one second problem. So problem 2, find where the line x minus 1 by 2 is equal to 2 minus y by 3 is equal to z plus 3 by 4 meets the plane meets the plane meets the plane 2x plus 4y minus z minus 1 is equal to 0. So we have a line, we have a plane, we need to say where it meets, right? Where it meets. So very simple. So just for understanding, I'll draw a very simple diagram, right? Just for understanding purpose only. So we have a plane, right? We have a plane and we have a line. So we need to find this point of intersection, right? So we need to find the point of intersection. So see, this is not in symmetrical form, right? Because for symmetrical form, it has to be y minus. So we will change this to symmetrical form. So what is L? L is x minus 1 by 2. So what we'll do is we'll take minus outside. So we will have y minus 2 divided by minus 3. Now this is in symmetrical form, right? Just take minus outside. So we will have, if we take minus outside, we will have y minus 2. Bring that minus 2 below. So is equal to z minus of minus 3 divided by 4. So you should always have in the form x minus alpha by a, y minus beta by b, z minus gamma by c. You should always have minus here. But here you have plus, so I'm writing this as minus of minus. Right now it is in symmetrical form. Right now it is in symmetrical form. So I can see 1 comma 2 comma minus 3 is one coordinate that we know, and direction ratio is 2 minus 3 4. So we can write the equation of this line which are already given, right? Let us say it is equal to some k, right? Now remember, any coordinate will be of the form, what form? So any point will be of the form x minus 1 by 2 is equal to k, y minus 2 by minus 3 is equal to k, z minus of minus 3 by 4 is equal to k. That means x is equal to 2k plus 1, y is equal to minus 3k plus 2, z is equal to 4k minus 3, right? So that means any point on the line will be of the form 2k plus 1 minus 3k plus 2, 4k minus 3. So any point will be of this form only. So depending upon the value of k, you can get all the points, right? Okay. Now, this is any point on the line. Now, for the point of intersection, this coordinate has to lie in this plane. Yes or no? For the point of intersection, this coordinate has to lie in P. So, this coordinate this coordinate has to lie in P. This coordinate should lie in P. That is P is plane, right? P is the plane, L is the line. Because then only we can find the point of intersection, right? So that coordinate has to satisfy P, right? So this lie on the plane P. What is a plane P? It is 2x plus 4y minus z minus 1 is equal to 0. So x is 2k plus 1. 4 into y is minus 3k plus 2 minus z minus 1 is equal to 0. So we will have 4k plus 2 minus 12k plus 8 minus 4k plus 3 minus 1 is equal to 0. So 4k minus 4k. So we will have minus 12k. 8 plus 2 is 10. 10 plus 3 is 13. 13 minus 1 is plus 12. So that means k is equal to 1. Right? So k is equal to 1. So that means you substitute k is equal to 1 here. So we have k is equal to 1. So k is equal to 1. So the any point of the coordinate is 2k plus 1 minus 3k plus 2, 4k minus 3. So since k is 1, this will be 3, will be minus 1, will be plus 1. This point is 3 comma 3 comma minus 1 comma 1 is the point where the line meets the plane. Is it clear? It's a very simple problem all are. It is based on planes and lines, right? It is based on planes and lines. Okay. We'll move on to problem number 3. So you can do any problem like this, right? So I'm not doing more than one problem in one method. If they give line and if they give plane, if they ask us to find the point of intersection or where the line meets the plane, you need to follow this method, right? I'm not doing more than one. I'm not doing more than one or two problems. All are very easy problem only, right? You just have to find the coordinate xyz coordinate by putting that is equal to k. Make sure that it is in this form. After that, you substitute this coordinate in the plane. You will get the value of k. Substitute back k here. You will get the final intersection. This is the general method, right? In the practice questions, I'll give you more problem on this. Okay. We'll move on to problem number 3. Find the ratio. Find the ratio. Find the ratio in which the join of in which the join of 2 comma 3 comma 1 and minus 2 comma 1 comma minus 3 is cut by the plane is cut by the plane x minus 2y plus 3z plus 4 is equal to 0. Find also the coordinate of find also the coordinates find also the coordinates of the point of intersection. So find the ratio in which the join 2 3 1 and minus 2 1 minus 3 is cut by the plane. Find also the coordinate of point of intersection, right? Okay. See, first we will recall one thing and then we will do this problem. So in the 10th standard, you have studied internal section formula and external section formula. Just recall that. What is internal section formula? Internal section formula. In coordinate geometry, you have learned, right? In 2D. So if this point A is x1, y1, and if this point B is x2, y2, and if there is a point P, right, let's say it is x comma y, that divides this line in the ratio of m is to n. it need not be a midpoint, right? P is any point that divides the line in the ratio of m is to n. Then what about the P? What about the coordinate P? This P of x comma y is given by mx2 plus nx1 divided by m plus n, my2 plus ny1 divided by m plus n, right? See, you have studied in 10th standard itself, right? Just try to recall that internal section formula and external section formula. Just as of now, we'll stick only this, right? Internal section formula. If any point P that divides this in the ratio of m is to n, then this point P is the coordinate. This coordinate of the point P is given by mx2 plus nx1 divided by m plus 1. This is for 2D. This is for 2D, and similarly for 3D, we will extend this. You will extend this, right? As of now, you just remember this. So what they are given is find the ratio in which the joint. See, we have a plane, right? We have a plane. We have a plane, and we have a line. Find the ratio in which the joint. So you need to join these 2 points. So we'll have a line, right? So this point is 2 comma 3 comma 1, and this point is minus 2 comma minus 1 comma 3. Let us say this is a point of intersection. Now you need to find the ratio m is to n, right? Find the ratio in which the join of 2 comma 3 comma 1 minus 2 1 comma minus 3 is cut by the plane x minus 2y plus z equals to 0, and also find the point of intersection. Very simple, right? So you just have to find the this ratio m is to n, right? So what is the equation of this line? Very simple, right? You know two coordinates, but any one coordinate is enough to find the equation of line, and you need to find the and you need to know direction ratio also, right? That is, if you want to write the equation of line, I have already said you should know any one point, you should know any one coordinate on that line, and you should know direction ratio, right? But here we know two coordinate. What is the direction ratio of this line? It is nothing but x2 minus x1, y2 minus y1, z2 minus z1. This is a very basic concept, right? Direction ratio is nothing but direction ratio of this line is x2 minus x1, y2 minus y1, z2 minus z1. So let us let L be the line. Let L be the line joining 2 comma 3 comma 1 and minus 2 comma 1 comma minus 3, right? So what is the direction ratio of this line? x2 minus x1, y2 minus y1, z2 minus z1. The direction ratio is minus 4, minus 2, minus 4, right? Direction ratio is minus 4, minus 2, minus 4, right? Okay. Now, you know two coordinate, right? Let us take one coordinate, right? So let the coordinate be, let the coordinate on L be, you can take any one. I'm taking 2 comma 3 comma 1. So you know one coordinate and you know direction ratio. What is the equation of this line? It is x minus alpha by a, y minus beta by b, z minus gamma by c. So here this is our alpha, beta, gamma, and this is our ABC. So we have x minus 2 divided by minus 4, y minus 3 divided by minus 2, z minus 1 divided by minus 4, right? This is the equation of this line. Let us say it is equal to some k. Now we will find this point, right? Let us call this point as q. Let q be the point where the line meets the plane. Let q be the point. See, you can also take the coordinate to be minus 2, 1, minus 3 also. You can also take alpha, beta, gamma to be this point also. You can take anything because you need to know one coordinate and direction ratio. Yeah, but you know two coordinate. You can take any one, right? Okay. So any point. So what about the coordinate of L? So coordinates of L will be of the form sorry. So minus 4k plus 2, minus 2k plus 3, minus 4k plus 1, right? So any coordinate on L will be of the form minus 4k plus 2, minus 2k plus 3, minus 4k plus 1. Now we need to find the point q, right? So let q be the let q be the point. Let q be the point where line L meets the plane P, right? So what is the plane? The plane is x minus 2y. The plane is x minus 2y plus 3z plus 4 is equal to 0, right? Now we know any point on line will be of the form minus 4k plus 2, minus 4k plus 2, minus 2 into y. So y is minus 2k plus 3 plus 3 into z, minus 4k plus 1 plus 4 is equal to 0. So simplify this. So we will have minus 4k plus 2 plus 4k minus 6 minus 12k plus 3 plus 4 is equal to 0. These two will get cancelled. So we will have minus 12k. So 2 minus 6 is minus 4. Minus 4 plus 4 will be 0. So we will have plus 3 is equal to 0. So we will have 12k is equal to 3. So we will have k to be equal to 1 by 4. So k is equal to 1 by 4. K is equal to 1 by 4. X minus 2y plus 3 is it? Just a minute. Okay. K is 1 by 4, right? Okay. Now that means what is the point Q? Q is the point of intersection. So the Q point is given by minus 4k plus 2, minus 4k plus 2, minus 2k plus 3, minus 4k plus 1. So if you substitute k to be equal to 1 by 4, so 2 minus 1 is 1, will be 2. So 2 plus 3 is 6, 6 minus 1 is 5. So 1, 5 by 2, 0. So 1 comma 5 by 2 comma 0 is the point of intersection, right? So this point is 1 comma 5 by 2 comma 0. Now we need to find mn. We know q also. Apply this formula. You will get the value of m is to n, right? Now q divides the line in the ratio of m is to n, right? Q is the point of intersection. Q is the point of intersection, right? Okay. So Q, let us call this point to be A, right? Call this point to be B. Now Q divides AB in the ratio of M is to N, right? Q divides AB in the ratio of M is to N. So what about the coordinate of Q? That Q coordinate is given by, you just have to extend for 3D, right? Instead of P, I'm putting Q here. So that point will be given by mx2 plus nx1 divided by m plus n, my2 plus ny1 divided by m plus n. Since we have one more coordinate, mz2 plus nz1 divided by m plus n. This is the formula for q in 3D, right? Now you know q, you know x1, x2, x3, y1, y2, y3. Substitute back here, right? So therefore, what is q of x comma y comma z? Q of x comma y comma z is nothing but intersection point that we know is 1 comma 5, 1 comma 5 by 2 comma 0. And what is our x1? What is our point A? A is 2, 3, 1. A is 2, 3, 1. And B point is minus 2, 1, minus 3. This is our x1, y1, z1. This is our x2, y2, z2. So it will be mx2 plus nx1 divided by m plus n, my2 plus ny1 divided by m plus n, mz2 plus nz1 divided by m plus n. Right? Now equate this and find the value of mn. So when I equate the first coordinate, these two are equal. That means every term has to be equal. So we will have minus 2m plus 2n divided by m plus n is 1. And let us take equate third coordinate, right? Because it is 0 here. So it will be easy for you to understand. So we will have minus 2m plus 2n is equal to m plus n. This is I'm equating first term, you will have this, right? So if I take these two terms that side, so we will have this will be plus 3m will be minus n is equal to 0. Call this as 1. And equate the third couple. So it will be minus 3m plus n divided by m plus n is 0, right? So equate this. This is 1, this 2, right? So we will have minus 3m plus n is 0. Call this as 2. Now solve for 1 and 2. Now solve for 1 and 2. So we have 3m minus n is 0 minus 3m plus n is 0. I think you'll be getting infinitely many solutions here. Yes, you'll get infinitely many solution, but no problem, right? You just have 3m to be equal to n, right? So that means we need to find only ratio, right? So that means m by n is equal to 1 by 3. So that means m is to n is 1 is to 3, right? We need to find only ratio, right? So from 1 we have this. You will have infinitely many solutions. It's a homogeneous system of equations. So m is to n is 1 is, so it divides in the ratio of 1 is to 3. Is it clear? Very simple. I'll repeat. Find the ratio m is to n in which the joint is cut by the plane x minus 2y plus 3z plus 4 is equal to 0, and also find the coordinate of point. Q is the point of intersection, right? This coordinate is given by 1 comma 5 by 2 comma 0. You apply section formula, you can easily find the value of m and n. Okay. To prove that the distance prove that the distance just a minute. I have an important call. Yeah, I'll give you an exercise problem. You just try this to prove that the distance of prove that the distance of the prove that the distance of the point of intersection of the line x minus 3 is equal to 1 by 2 I minus 4 to z minus 5 plane on the plane x plus y plus z is equal to 17 from the point three comma 4 comma. So just take this problem exercise to do this problem now. So I'll back in 2 to 3 minutes. Okay, so I will resume the classes later, right? So I will continue this from this one of the fourth problem. So I have a very important call now. So I have an important work. So I will resume the classes from the fourth problem, right? So I'll update the class timing in Telegram group later, right? So thank you, thank you.